Good morning. Today we're talking about radioactivity and radiation. And to that end, I have this device right here, and it looks like it's the speaker system for a karaoke machine, but it's not. Instead, what I have here is what we call a Geiger counter. And what a Geiger counter does is it detects particles of radiation. And every time it detects a particle, it makes a click. Maybe you're even seeing the light down here flashing every now and then. It will also have a visual cue. This one is set for 1,000 units of radiation per minute, which means when it detects equivalent amount of radiation in that time, it makes a sound or flashes the light. So what does that mean? It means we've got radiation around us all the time. We're really focused on the radiation that deals with nuclear radiation, the three versions we talked about, alpha, beta, and gamma radiation. Remember what an alpha particle is and how it affects the mass of your atom. Remember what a beta particle is and how it affects the charge or mass of your atom. And then gamma radiation is a type of radiation that is super high energy. It doesn't really change the mass or element the way that we would expect it to, but it does actually still remove particles from the atom. In trying to detect radiation and using a Geiger counter, what we do is when the Geiger counter comes into contact with a radioactive source and it detects that radiation, it will make that sound. So I have a radiation source right here. And watch what happens when I bring it up to the speaker or bring it up to the detector. You can hear all the clicking. That indicates this is giving off a lot of radiation. The more clicking, the more radiation is being given off. So then that leads us to another question, and that's this. What can we do to stop the particle radiation? And the answer to that question, hopefully you have seen or understand, depends upon the type of radiation. I'm going to go back to my radiation source right here again. If I want to stop the alpha particles, paper, just a piece of paper will do. So I'm going to block all of the alpha particles that are coming out of this radiation source. Ready? Didn't hear much of a difference, did you? Must mean that there are other forms of radiation that are coming through. To block beta radiation, I need something a little bit thicker than your skin or paper or something like that. Maybe some foil would do a pretty good job. So again, let's listen. This will block out all the alpha and all the beta. Still not too much of a change. What does that mean? It means this source must be emitting some pretty good gamma radiation. How do I stop gamma? I need something a little bit more strong for that, and that's lead. That's why nuclear reactors and bomb shelters are lead lined. So watch. When we put the lead in between, it stops the sound right away. It stops the particle emission and therefore does the job. That being said, there's a fun little piece of nice little history that's kind of cool. One of them has to do with Fiesta ware. Fiesta ware was made in Mexico, still is made in Mexico, but the original Fiesta ware used a glaze that was made out of something called urinal acetate. And urinal acetate has sort of a yellowy looking color to it and is radioactive. What does that mean? The urinal portion comes from uranium. What it means is that these guys are radioactive. Imagine putting your morning milk or orange juice in there every morning. You'd be radiating yourself every day. So, the Mexican government has changed that, and those potters who make Fiesta ware now have different glazes, but it's certainly something to be aware of. If you've got some old piece of Fiesta ware, you might just be radiating yourself every morning. On that happy note, we'll see you later.